Hello everyone, I am José Ángel Gumiel, computer engineer with a master on Advanced Electronic Systems. At this moment, I am pursuing my PhD on Electronics and Communications, focused on safe automotive mechatronic systems. During my education, I had an interest for cybersecurity, including data anonymization and encryption algorithms. Since 2018, I have been working at Techniker, our research and development center, where I developed my master thesis, a console for a three-phase power inverter on FPGA. During my internship, I was also involved in other projects where some of my tasks were related to cybersecurity. Since I began my doctoral thesis, I have been in constant cooperation with BATS, a global Tier 1 supplier. Since April 2022, I have been also working at the facilities, and I have been in contact with several OEMs, where I have seen firsthand the problems both are facing. That has given me enough background for the present research. In this presentation, I will first analyze the current disruptions and challenges in the automotive industry. Next, I will explain the differences and similarities between safety and security, followed by a focus on cybersecurity, which aims to highlight the work that needs to be done in different areas of the organization. Finally, the issue of vehicle aging is addressed, and the exposition finalized with conclusions and future work. I call electronization the process of integrating more and more electronic systems into the vehicle. At this point, automobiles have become computers on wheels, with 90% of the technological innovation being electronics. The following chart shows the percentage of the total vehicle cost that is electronics. Right now, we are at more than 35%, but in 2030, half of the total cost of the vehicle will be addressed to electronics. But what happens when technology comes to market quickly, but traditional players cannot adapt it? Disruption. Traditional suppliers have some background in mechanical engineering, but not in electronics. Other technology companies, whether startups or giants, can now enter the automotive sector. But it is difficult for them because they lack the trust of the OEM or because they sometimes need to integrate a mechanical mechanism into their systems. In this situation, Tier 1 suppliers must make the leap to designing mechatronic systems or, in other words, high value-added parts. These disruptions bring new challenges. Suppliers must introduce electronic knowledge to manufacture mechatronic parts. This, per se, is a difficult task, but communications and connectivity also add complication. As protocols must be secure, the functionality must not be compromised, and data must not be corrupt nor leaked. Cybersecurity is not a trivial issue. How do you design secure products? What is the impact on the organization? What measures must be taken and where are they implemented? What happens as the vehicle ages? These are some of the questions that will be the focus of this presentation. Safety and security are two important concepts in the automotive industry, and while they may seem distinct, they are closely related. Safety focuses on minimizing the risk of harm to people due to malfunction or failure of the system, while security focuses on protecting the system from malicious attack or unauthorized access. However, both concepts are concerned with identifying and managing risks and ensuring that the system behaves in a predictable manner. In practice, this means that security considerations must be integrated throughout the development process, from the initial design phase through to the test and validation phase. In addition, there may be areas where safety and security requirements overlap, such as the design of secure communication protocols or the use of redundant components to improve system reliability. Therefore, it is important for automotive designers to consider both safety and security requirements when designing and implementing electronic systems. This Venn diagram shows some of the standards and guidelines for road vehicles. On the one hand, there is ISO 26262, functional safety, with which the Automotive Spice Guideline has many similarities. From this standard came ISO 21448 and the safety of intended functionality. Due to the specific needs of advanced driving assistance systems and other tools based on computer vision or artificial intelligence. Finally, we have Cybersecurity, which starts as a section of the second edition of ISO 26262, but is now an entire standard and is all-encompassing. If a system is not secure, it cannot be safe. Although academia is aware of cybersecurity, this knowledge has not yet been assimilated by the industry. Company suppliers are unclear about the scope of cybersecurity, the impact on internal processes, and the cost it supposes. On the other hand, OEMs do not seem to be clear either, sometimes issuing RFQs with very vague specifications or just the opposite, too strict for the category of the component. As we will see, cybersecurity is holistic and includes the office environment, project development, test development, production life, and the entire vehicle life. The next slides will analyze these scenarios one by one. An automotive company needs a secure office environment. They manage sensitive information and have daily meetings with customers. Project timelines are tight, so systems and networks must be up and running and can be compromised by an attack. Suffering a cyber attack, such as ransomware or project leaks, can damage the company's reputation. Some measures to protect the environment could be access control at the entrance to prevent unauthorized people from entering. Education is also important. Security is a culture, and employees must integrate it into the daily activities. Some other measures could be implemented by the ICT department. For example, network segmentation. It could be used to prevent potential exploits from spreading to other networks. It could also be combined with firewalls to monitor and control network traffic and be used to implement secure information access and version control services, such as Git or SVN. Today, VPNs are common, and it can be used to create an encrypted tunnel between the employee and the corporate network when connecting remotely. Finally, updated software fixes bugs and vulnerabilities, reducing the risk of a cyber attack. As we have seen, cybersecurity starts with a secure work environment, but hardware and software engineers must create cybersecure systems. OEMs are already asking for ISO 21434 compliance, and Tier 1 suppliers are responsible for it. This standard applies to the entire product lifecycle and does not distinguish between hardware and software. The component is a system. For those familiar with ISO 26262, there are some similarities, as will be shown on following slides. The first part of the development phase is concept definition, the item, its operational environment, and its interaction with other items must be clarified. Later, through threat analysis and risk assessment, potential harm and security goals are defined. Finally, a cybersecurity requirements specification document is created. During the development phase, the following should be considered. The protocol is important. It is not recommended to develop a critical system using an insecure communication protocol. If the system is not to be manipulated, a trusted platform module can be considered to authenticate that it has not been tampered with by third parties. In software development, best practices must be followed, including modularity, abstraction, layering, process isolation, and domain isolation. Auto-share architecture is a good example that can be considered for modular design. If the system is to be calibrated at the end of line, the EEPROM should be lockable, so that the values cannot be tampered with ever again. The design must always be tested against vulnerabilities. The first step is to ensure that the security goals have avoided the different threats. Additional tests are needed to ensure that the system is secure, Hacking tools can be used to perform penetration tests, vulnerability scans, security scans, and communication analysis. The hacker's role must be played to secure the system. Hardware and software aging is a problem. Hackers gain more knowledge about this technology and more vulnerabilities appear. When a bug or vulnerability is discovered or reported, it is important to update the software. Over-the-day updates makes this possible, but the channel also needs to be secure. Do you imagine a hacker uploading a compromised software to your systems? The test department collects prototypes and products to analyze their behavior, robustness, or power consumption. They manage sensitive information, so there is usually a high wall to prevent anyone from seeing the work environment. No photos are allowed in this area, so employees use digital cameras instead of smartphones, as they are not connected. The data collected from the test must be protected, so a good practice is to have a separate network and an encrypted database with a backup policy. Once a product is designed and tested, serial production begins. Manufacturers are now highly automated and interconnected, so they must be secure. Some measures include control access to the factory, double firmware verification to ensure the process has been done correctly, and locking the EEPROM once the data has been recorded. The vehicle itself must be secure to protect the electronic systems. Some measures OEMs can take include secure goods, intrusion detection or prevention systems, encrypted communications, and the use of new technologies such as NFT or blockchains to ensure data is not altered. Connectivity could make vehicles vulnerable. For example, Charlie Miller and Chris Balasek explained at Black Hack conference how they hack a connected vehicle. They also saw a report from Wired magazine what actions they could perform on a moving vehicle remotely. Here on this video, we can see how this group of hackers can manipulate the vehicle to actionate the windshield wipers.
Okay, do it. Do it.
We can also see how they are turning off the engine while the car is on the road. At this part of the video, we can see how they are manipulating the infotainment systems. This group of hackers can turn off the volume of the radio. They also can introduce images onto the screens, and this can provoke the alteration of the driver and provoke an accident. We have just seen how a vehicle can be hacked, but what if I told you that the environment can also be hacked? Yes, traffic signals and lanes can be hacked. This vulnerability was discovered by McAfee. The team placed tinfoil for the first sample and black tape for the second on two 35 miles per hour speed limit signals. The vehicle used cameras to read the signals, and although a human driver could interpret them correctly, or even not notice they were there, the computer system interprets 45 miles per hour in the first sample and 85 miles per hour in the second, tricking the cruise control and accelerating the vehicle. This poses a risk to the driver, passengers, and other road users. Here is another hack known as a phantom attack. An image is projected onto the road, creating fake traffic lights, fake road lines, or human images. Here, a few examples are shown. In the first case, a 90 miles per hour signal is projected onto a tree. A human driver will know that this is not a real signal and it's impossible, but the vehicle will misinterpret it. The same goes for the second image. There is a curve projected onto the road. The vehicle interprets it as a road lane by turning the steering wheel. The last image is a projection of a man on the road. Although the vehicle has additional technology like radar and LiDAR, and they don't detect anything at all, the vehicle stops as a safe reaction because the camera sees a human being. The average age of the European vehicle fleet is 12 years old, as shown on the chart below. When these cars had some electronic systems, they were mostly not connected, which means fewer potential threats. By 2025, we expect more than 400 million connected vehicles. What will happen as they age? Connected mobility brings new challenges. Each vehicle will generate more than 25 gigabytes of data per hour, and all this information needs to be secure. Electrification is also a critical issue, as some vulnerabilities have been identified. These threats need to be addressed and the vehicle updates in a secure manner. Security is a hot topic in the automotive industry. It's becoming more important day by day. OEMs and Tier 1s need to catch up in this area, as they still lack knowledge and often misunderstand the requirements. Both need to move forward together on this knowledge path. Cybersecurity knowledge from academia needs to be brought into the automotive industry. The electric vehicle will impact the smart grid, and both need to be secure. The biggest concern for the future is what happens when connected vehicles get old. How many years will OEMs and suppliers support a vehicle? Thank you for your attention. The presentation was intended to be a wake-up call to OEMs and suppliers about the importance of cybersecurity and its scope in the automotive industry. I hope you found it interesting.